Hello, this is Mr. Wakefield, and we are still in the Math 130 prerequisite review packet. However, we are now looking at fractional exponents. and what we have here is, excuse me, a situation where we have an exponent that's not your normal exponent, obviously. I mean, as you guys know, when you have, for example, an exponent of 2, it means to multiply twice, right? 3 squared means 3 times 3, which of course is 9. But then, what do you do with the fraction exponent, though? 3 squared means 3 multiplied twice. How do you multiply something to the 2/3 power? Or in particular, how do you multiply something 2/3 times? Okay, that doesn't make sense, right? Normally. All right, so what does a fraction exponent mean then? Well, these two rules give us some idea of that. This rule is only when the fraction exponent has a 1 on top, okay? But this one allows for there being a 1 on top or another number, okay? And so, because of that, it's easiest just to use this rule only. I put this rule here in case you really want to use it, but you only use it when the number on top is 1 of the fraction exponent. But this one you can use anytime, whether the top number of the fraction exponent is 1 or something else. Okay, so I like to use just this one just to keep things simple. Just you only have to memorize one formula. Okay, it makes things simpler than having to memorize 2 formulas. And in particular, this formula right here, it says that you could use either one of these two things to be equal to this. Okay, I like to use this one. This one, sometimes it's just as easy as this one, but sometimes it's harder. So I like to use this one in particular. So that's what we're going to focus on right here is this right here. Okay, this formula with this answer. This answer is not bad. It's just that it's a little bit harder to calculate sometimes. So we're just going to focus on this right here. Let me show you some example problems here. Okay, on the next page of the packet, it says right here that 8 to the 2/3 power. Well, if we use the formula that we have right here, okay, following the formula, it says that if the base is 8, okay, the thing taken to the fraction power is 8, and then you have 2/3 right here, it's saying that the numerator goes outside the bracket. You make a bracket. Okay, let's go ahead and make a bracket right here. You put the 2 on the outside, okay, because the m is the top of the fraction. The n is the bottom, and that's going to be that index number that tells you what kind of root you have. Okay, since the number is 3 for the bottom of the fraction, that means it's going to be a cube root. Okay, a cube root. All right, if that number on the bottom of the fraction had been 4, then it'd be a 4th root. If it had been a 2, then it'd be a square root. Okay, so it tells you what kind of root you have. Now, the number that goes inside of the radical is the number that's taken to that power. Okay, in this case, it's 8. And so we've now successfully set it up. According to the directions, it says to rewrite it in radical notation first. I need you to do that, okay, when you do these types of problems with fraction exponents, because your calculator should be able to calculate this thing straight the way, if you enter it correctly into the calculator, you can calculate it straight right off the calculator. But I want you to show me, by showing your work by putting it in radical notation, that would show me that you understand the relationship between a fraction exponent and this setup right here. That's very important, okay, for your future work that you do. And so you need to set it up in radical notation. Now you can go ahead and evaluate it, which means just to calculate what this is equal to. Okay. Now again, as been discussed, I'm sure you've heard this before, whether it be in another video or somewhere else. Again, when you have a problem that has no variable in it, and you have to evaluate or calculate what it's equal to, we do order of operations. Please excuse my dear Aunt Sally. Okay, parentheses first, then exponents, then multiplication, division, and so on. So we calculate what's the inside the parentheses before we do the exponent that's on the outside, in other words. So in other words, we figure out what the cube root of 8 is, since that's inside the parenthesis. The cube root of 8 is equal to 2, because 2 to the third power is 8. That's what it comes down to. Okay, and so 2 to the second power is what we end up with. And then we do our exponent. Final answer is 4. Okay, so put it in that radical notation first, using the formula that we have on the previous sheet. Okay, and then do order of operations to calculate what it's equal to. Okay, now, what do we do when we have negative signs involved? Okay, we got to be a little more careful with that. Something from a different video here, let's review, is that when you have a negative sign in front of a base and an exponent, okay, something taken to a power, and there's no parenthesis like there is in this problem. Okay, when you have a negative sign, no parenthesis, and then a base and an exponent, something taken to a power, that negative means negative 1 times, assuming it's at the beginning of the problem, negative 1 times, and then the 4 squared. In the similar way, in this problem, what you need to do is you need to say that this is negative 1 times, and this is because there's no parenthesis there. Just like here, there's no parenthesis, whereas here there is. We do that kind of thing differently. We'll talk about that too. But, so it's the same thing here. Negative 16 to the 1/4 power, no parenthesis. You do negative 1 times 16 to the 1/4. Okay, and so that's exactly what I'm going to be writing here. Once you get that negative sign out of the way, so in other words, if you get negative signs in these fraction exponent problems, it's best to get them separated from the number taken to the fraction power first. Then you can take that number to the fraction power, put that in radical notation, and then go from there and finish off the problem. Okay, so that's what I'd like you to do. Okay, if you have a negative in front with no parentheses, separate it like this. Okay, I'll tell you how to deal with this one over here in a second. Okay, actually the negative's not going to cause as much trouble there, but we'll get to that in a minute. So this is what we do here. Then we do, like I just said, we then put this in radical notation. Okay, one of the reasons why it's important to separate the negative 1 is because it's not the negative 16 that's taken to the 1/4 power, right? Okay, as we talked about in a few minutes ago here when I showed you that other example. Okay, with the negative 4 squared. All right, it's the 4 that's taken to the second power, and the negative is separate. Same thing here. It's the 16 taken to the 1/4 power, so we need to separate the negative 1 in order to set up the radical notation correctly. So here's how it works. Using that second formula, which I recommend just to make things simpler, but you could use this formula here, and I'll show you how it's the same. But using this formula, we get what? We get 16 to the 1/4. Remember, the negative 1 is separate. Okay. 16 to the 1/4, the 4 goes here, the 1 goes out here, and then the parenthesis, and then the 16 goes inside the radical. Let's write that down. Don't forget to bring down that negative 1 there. Okay, it's separate, but it's still part of the problem here. So we write this down right here. Now notice that when you take something to the first power, you guys, you really don't need to write that, because when you take something to the first power, it doesn't really change it, does it? If I take, for example, 5 to the first, it's still just 5, right? Okay, it's nothing changed. And so that's the reason why you could use this formula if you wanted to here. Okay, if you use this formula, it would have been 16 to the 1/4, again, the negative 1 is separate, equal to just 4. You don't need to do anything with the 1, and it would have just been 4 to the 4th root of 16 right there. Okay, the 4th root of 16 is the same thing as the 4th root of 16 to the first power. And so that's why you could have just said negative 1 times the 4th root of 16. You could have written this if you wanted to as well, because that 1 that's on the outside of the bracket there isn't going to make any difference. Okay, you take something to the first power again, it doesn't change anything. So you could have written this, but like I said, I like to just keep things simple by using that second formula all the time, so you only have to focus on one formula all the time when we do these problems. Anyway, so using order of operations, which we do after we put it in radical notation, because we have no variables, we just have to calculate this thing with no variables getting in the way. So we do parentheses first. The fourth root of 16 is 2, because 2 to the fourth power is 16. Then you do exponents, and as we've already hinted at, that's not going to change anything, but we still go through that process since we're using the second formula here. 2 to the first power is 2. And then the final answer, after we multiply by the -1, multiplication comes after exponents, would be -2. And if you did it this way up here, it would have been the same thing. It would have been -1 times the 2. This would have been equal to 2. And then you would have gotten the same answer, -2. Okay. Let's do one more here. So we have, remember, and again, a reminder here, that when you have a parenthesis next to an exponent, doesn't matter if it's a fraction exponent or a regular exponent, okay, a little reminder here, when you have again, this is from that same sheet I was showing you earlier with the -4 squared, if you do have the parenthesis there next to the exponent, then the exponent applies to the entire parenthesis. So that's why in this problem, it's -4 being taken to the second power, but in this problem, it's just +4 being taken to the second power, with the negative being separate from that, separated by the multiplication here. Okay, so in the same way, this right here means that 1/3 is applying to not just 64, but -64. So when you have an exponent next to a parenthesis, it applies to the entire parenthesis. So how do you take something to the 1/3 power? Well, of course, we don't do that normally. It's not like taking it to the 3rd power or the 4th power. But again, we have our formula, okay, which says what? Using our formula again here, okay, -64 to the 1/3. I know there's no parenthesis here, but I'll show you how to handle that. So you put the 3 here. You put the 1 on the outside. Again, you could just do it this way too, because the 1's on the outside, it's not going to make any difference. And then you put the entire parenthesis inside of here. So whatever's being taken to the fraction power, that whole thing goes in here. Okay, so we get what here? We get 3 here as the index or root number. The -64 goes in here. And then the 1 goes outside that parenthesis that you make, according to the formula. So we get, again, a situation where we put it in radical notation. So now we do the order of operations to figure it out. So we do parentheses first and then the exponent. What is the 3rd root of -64? Well, -4, if you multiply it 3 times, okay, is equal to -64, and so therefore the 3rd root of -64 must be -4. Okay, and so -4 to the first power. Then we take the parenthesis, whatever's inside of that, which we now realize is -4. We take that to the first power, and again, that's not going to change anything. Okay, remember, we're not taking 4 to the first power because of the parenthesis. The parenthesis means we're taking -4 to the first power. Okay, just a reminder there. And so it doesn't change anything. It makes it -4. Okay, and so that's fraction exponents, you guys. Okay, and that concludes this brief video. All right, I want to make sure that you understand how to deal with an exponent when it's a fraction.